So a log and an exponential are very closely related to one another. If we have a log, we can change it to exponential form. And what do we do with that? How do we do that? Do you remember? The base of the log becomes the base of the exponential. And then we go across the equal sign. So it's a to the y power equals x. One of the last things that we did when we were in college algebra. So we can go back and forth between the two notations. All right, then getting into our properties. If you have the log of two things multiplied together, we can break them apart by doing what with their individual logs? Remember? Log base a of x plus log base a of y. Okay, if we have a log of two things being divided, what would we do with the individual logs? So that's log base a of x minus log base a of y. The minus is always the one that was on the bottom. Likewise, if there were a couple things on the bottom, you'd subtract them both off. So if it was like a yz, you'd have minus log base a of y minus log base a of z. Subtract each one. Okay, the next property. If you have the log of x to a power, you can multiply it with that power. It comes down on the front. It's r times log base a of x. All right. The common log is often just written as log of something, and it's understood to be a log base 10. So that was the one that we saw most often in college algebra. You just see a log anytime that base isn't written. It's log base 10. The natural log we see as an ln, and that represents a log base e. In calculus, the natural log is the one we are going to see all the time. It works better with all the different calculations we're doing, so that is our go-to. We'll always want things as natural logs if we need a log. All right, so yesterday we talked about graphing exponentials. Let's graph a couple logs. You guys have all that down? I do too. Okay. So we are going to graph the common and natural logs. So when we graphed an exponential, we just did 3 points. We plugged in -1, 0, and 1 for our x's yesterday. When I have f of x equals the natural log of x, f of x is the same thing as y. So that's like saying y is the natural log of x. If I wanted to change this to exponential, what's the base of this natural log? It's an e. So what that means is e to the y power equals x. So when we graph exponentials, we put in -1, 0, and 1 for the exponent. Which one's the exponent this time? The y. So I'm going to plug in those 3 numbers for my y. e to the negative 1. What does a negative exponent do? Flips it, so it's going to become a 1 over e. What's e to the 0? Anything 0 power is 1, and then e to the first is e. Alright, I know we don't usually use calculators, but for the purposes of helping us graph, type 1 divided by e in your calculator. Give me a decimal. What is 1 divided by e?
3, 6, 7, 8.
Okay, so it's about a little less than 0.4. So that's your x, and your y is negative 1. Next point, 1, 0. E is like a 2.7 something, 2.78, 1. Will you ever put in a power and get 0 for an answer? If you take e to a power, can you get 0? No, just like yesterday, we couldn't get 0. Okay, that's fine. Thank you, Jordan. All right, so we can't ever actually get 0. So remember, our exponentials had a horizontal asymptote. These end up with a vertical asymptote. So it's going to look like that. Sorry. We're never actually touching the axis. So I want you guys to sketch a graph of the second one. So I want you to graph g of x, that's like y, equals log base 3 of x. To the y equals x. So if you plug in negative 1 for your y, you get 1/3. 3 to the 0 is 1. 3 to the first is 3. So 1/3, negative 1, 1, 0, and 3, 1 are plus on our graph. So when we graph these, we are doing it writing it in exponential form and graphing it like that. Is this all good? I want to do just a couple more things here. Okay, if I were to use the laws of logarithms to combine this, I don't know log base 2 of 80. That's like saying 2 to what power equals 80. And I don't know log base 2 of 5. That means 2 to some power equals 5, and I don't know what that would be. But if those logs are subtracted, how could I put them together? The log base 2 just goes out in front. And then we do 80 divided by 5. So that would be 16. So if you know what a log means, it's like saying 2 to what power equals 16. So you might be able to look at it and know. If you didn't remember, you could set it equal to x and rewrite it. It's like saying 2 to the x power equals 16. You know what that would be? 2 to the 4. equations with logs and exponentials. I think that's the last little piece we have to cover. So I want to solve for x on each of these. Okay, so what should we do on this first one? Natural log of x equals 5. Yeah. This is an e here, so you could change it to exponential. So it says e to the 5th equals x, and we can leave it like that. B. The natural log of x squared minus 1 equals 3. So this is a base of e. So that means e to the 3rd power equals x squared minus 1. Then what would we do? Couple things to mention here. If you add a square root, what do you have to have? Okay. With logs, the argument always has to be positive. I think we touched on that one when we did our domains in the previous section, so we've talked about that. But since I'm going to have x squared minus 1, if I square it, does it matter whether it was a positive or a negative to start with? No, so it'll turn out to be positive either way. So I just get plus and minus the square root of e to the 3rd plus 1. C. 2 to the x minus 5 equals 3. Okay, so we could change it to a log base 2. Remember in college algebra though, we didn't like to do that because if we were using buttons on our calculator, did we have a log base 2 button to use? No. So remember we just added a log on each side of the equation? It's been a while. You guys remember that? So we can add, I'm just going to add a natural log. You can do either one. And we use the natural or the common log because those were the buttons we had. With properties of logs, what happens to this exponent? Okay, if I'm trying to get x by itself, I'm multiplied by the natural log of 2, so we should divide that. And then what would we do? Okay. Since we're not using calculators on the test, you wouldn't have to change it to a decimal. You can just leave it like that. Is that one okay? Last one. What would I do? Okay. All right. What happens if we have a natural log and an e? They cancel. A natural log is a log base e of e. Or another way to think about it. Okay, if I bring down this exponent. This right here is like saying e to what power equals e, which is just 1. Now if you didn't drop that because it's equal to 1, you'll still get an equivalent answer. It's just going to look a little bit uglier. But anytime we have a natural log of b, we could just get rid of it. So then to get my x by itself, what would we do? Subtract our 5. And then we would divide by -3. Not a pretty looking answer, but it works. Alright, so we need to talk about a few things. This is the end of the section. It's also the end of our review unit. So, you have that assignment that's due tomorrow. You've got a lot of time right now to finish that. I am also going to go ahead and give you the study guide for this unit. I know you guys aren't going to like it, but I'd really like to do the test on Monday. Because we took 1 extra day in this unit already. I don't want to burn up all of our extra days in the first chapter. I don't typically like Monday tests, but I think it's doable. We'll have tomorrow as a work review, answer question day. It is a shorter test. I think it's just, yeah, see, here's the last page of your test. It's blank. So it's only 3 pages instead of the typical 4, so it is a little bit shorter. So, is that all right with everybody?
I'm not gonna be